Okay, this is a quick video about taxonomy. So you're not going to just use taxonomy in inverts. You're going to be using taxonomy in pretty much every class that you take in biology, and something that you need to be familiar with. All right. Now, this isn't a very difficult thing to once you get your head around it, and it's a way to essentially put things into groups. Like if we think about organisms. It's not a very ingenious idea to go, oh, well, we want to group them up so we can say that these ones are like these, and we notice that there are similarities between these ones, and let's put them all into a group so we can classify these, so we can make sense of how they all fit together. You can build a tree of life, how closely they're related. Okay. So, in terms of diversity, we're trying to give it an ordered overview. So we can do not just biological organisms, but we can also classify all sorts of things. And this is a natural human instinct, a natural thing that we do as human beings when we're trying to make sense of the world around us, and in order to pass along information easily. So if you think about where you live, okay, then you could fill all of these in, and we're talking about from the most general to the most specific, and you could even go one higher. You could say the world, or they could say Earth. You could say the sun, solar system, whatever we call our solar system. You could say the Milky Way galaxy, and then there are even probably divisions of the universe that we might fit ourselves into. If you look at the astronomers probably would be able to tell us even more. But anyway, so you go from the most general to the most specific. So for us here, we're living at, let's say if I was recording this in A3, then we'd be in the Eastern Hemisphere. We'd be in the Australasian continent. Not really a continent, but Australasia, the nation of New Zealand, the state. Well, we don't really have a state, but you could say maybe North Island. We could say the Western Bay of Plenty, the city of Tauranga, the suburb of Windermere, and the street would be Windermere Drive, and then you could even go below that into room A3. You could say Bay of Plenty Polytech campus, then room A3. So you can classify where you are from the most general to the most specific. Okay. With biology, we use something called the Linnaean hierarchy to classify organisms. So this guy, Carl Linnaeus, he was in the 17th century, and he's sort of the father of modern taxonomy because people before that, they classified things as horses and as things like, they would have classified everything that was a jellyfish as grouped together as jellyfish. But he took it a little bit higher, and he sort of went, well, we could say all the things that are jellyfish-like organisms, maybe we'll put them into a different grouping. Maybe we'll put all the things that have hair into a grouping called mammals. And so he essentially established what we now know as the tree of life, and you can see how connected things are from the most specific, which are species, up to how far apart they are, how connected something is. For example, are you connected? Are you more closely related to a bacteria or a horse? Or are you more closely related to let's say jellyfish or a tree? So by using the tree of life, you can actually trace back and see where your common ancestor was, and see how closely you're related. Carolus Linnaeus, there you go, 1707 to 1778. He places organisms in relation to one another according to the similarity or dissimilarity, and this is an attempt to outline evolutionary lineages. Now, the funny thing is, of course, Carolus Linnaeus, he's often referred to as Carolus Linnaeus because he was so enamored with his own system that he actually changed his name from Carl to Carolus Linnaeus. But anyway, he had no idea about the idea of evolution, because Charles Darwin published his theory much later than that, and he didn't know anything about DNA, of course. But he just tried to group things according to what attributes they had. Or maybe things that have hair might all be grouped into one thing, or one grouping, or maybe things that have, let's say, what would be something that would be common to numerous things. Let's say all the things that have bilateral symmetry. Now, the problem with that is that maybe they have evolved in two different groupings independently. The same type of thing may have evolved independently, but it was the first attempt to classify things, and it was essentially on what you could observe about that organism. Okay, so examples. All right. So you could have a go at classifying these on your own. So try to draw a family tree or organize them in such a way that the relationships between the animals are obvious. Okay, so you don't have to use the Linnaean hierarchy, but be able to justify what groupings you've made. Okay, and so just go ahead and pause the video and try to draw or group these into, let's say 3 categories where you can group these into different. Those according to their similar characteristics. Okay, I'll give you a second now. Move on. Okay, so this is my classification, and you may have done something completely different. All right, so I just decided to go with colors to start. So a great white shark and a bottlenose dolphin, both kind of gray with some variation, of course. The great white shark being a lot more darker on top and whiter on the bottom. But anyway, they're kind of gray, brown, New Zealand fur seal, an Australian fur seal, and the pink, or kind of reddish, at least according to, they probably can change colors quite a bit, but the ones that wash up and that we've seen, that we've observed, have been fairly reddy, pinky color. Okay, so giant squid. So that's one way to classify these organisms. Here's another way. Okay, been the focus of a film, or never been in a film. Okay, so you can further classify these in really bad films, giant squid, or been in at least one good film, the great white shark, bottlenose dolphin. Okay, Jaws is a fantastic film, and the bottlenose dolphin. What dolphin movie was there? Well, let's see. Definitely. Oh, there were dolphins in one where they were treasure hunting in the Caribbean. Anyway, we've been at least one good film and only been in really bad films. Never been in a film, never even had a TV show. New Zealand fur seal, Australian fur seal. So, there you go. And this classification is based on media notoriety. So, you can classify things in lots of different ways, but in terms of biology, we classify them according to what features they have on their body, what observable things that they have that you can observe. All right. Now, this recently used to be things like hair and arms and teeth types and bone structure and things like that. Now we're able to use the tool of DNA, which is much more meticulous, mechanical, and maybe more structured in the way we can, maybe a little more accurate, a way to put a numerical degree on the separation of organisms. Anyway, so we start with kingdom Animalia. If we look at, if we go down and we'll have a look at these different organisms that we were classifying before. We'll start with Animalia. Okay, then we can go into phylum. Okay, and all of our organisms are going to be chordata, which means that they have a dorsal notochord or dorsal nerve cord running down their back. Okay, and a few other things, but we'll learn about that later. Another branch of the animals would be mollusca. Okay, so the snails and other things like that. But so the mollusca would be a different type of animals. Okay, so these ones are all grouped on having a dorsal hollow nerve cord and a few other things. And the mollusks, they all have a visceral mass, a mantle, and a muscular foot. Okay, so then we can go into cephalopods, chondrichthyes, and mammalia. Okay, so class Cephalopoda. These are all the fast-swimming, tentacled mollusks, big brains. They tend to have no or internal skeletons. Okay, no shell or an internal shell. Okay, as opposed to snails, which will have an external shell. So all the cephalopods, they have certain characteristics that are grouped together. Okay, and then chondrichthyes, these are the cartilaginous fish. Okay, so you'll have learned a little bit about that in mammals, birds, and fish. And then mammalia. Okay, so these generally tend to have hair, and they tend to what else do they have? They tend to produce milk and have mammary glands, and so these are grouped according to those characteristics. Okay, so then you've got Teuthoidea, all right, with the cephalopods. If we keep going down with the cephalopods, the Teuthoidea tend to have hooked tentacles, okay. Lamniformes, okay, this is a type of it's a type of shark, okay, and they've got a grouping, the Requiem shark. So it's a grouping of mostly pelagic sharks, and has to do with the shape of their teeth and some other groupings that we're not going to go into too much. Cetacea, okay, so whales, dolphins, and porpoises, and pinnipeds, okay, seals and walruses. So these ones are things with fur. These are obviously some difference. There are some big differences between whales, dolphins, and porpoises, and then the seals and walruses. Okay, so Architeuthidea. This is a type of squid. Lamnidae. Okay, again based on more on teeth shape and the like. And Odontocetidae, okay, so those are toothed whales, and then Odorheidae, so there's eared seals, okay, and then you've got this is the family, okay, and then we're on to genus, Architeuthis, Carcharodon, Tursiops, Arctocephalus. This tells you a little something about the particular grouping, so there might be several different species in the Architeuthis that all share a certain characteristic. Same with the Charodon and the Tursiops, so different dolphins that have some of the same characteristics. But then you've got the species. Okay, so the species is something that something becomes a species when it can only breed with other members of that grouping of that population, and produce viable offspring that can breed as well. So you can have like a lion and a tiger. So they would both be in the same genus of Panthera or something like. It's like Panthera, but they'll be, and so they can actually produce an offspring. But that liger, which is the type of offspring, is an interesting animal. It's even bigger than the tiger or the lion, and it has some characteristics of both. But it itself can't breed. It can't produce viable offspring. So those would be two different species, the tiger and the lion. But if you have a lion and a lion breeding, then they can produce a new lion, and that lion can go on to breed, and so forth and so on. So that's where you get the species. So Architeuthis kirkii, and you'll notice that the genus and species are written in italics. So you need to either write them in italics or underline them. And the genus, you'll notice all of these ones are capitalized. The genus is capitalized, and the species, though, is in lowercase names. So genus, and this is the convention Carl Linnaeus came up with as well, that you refer to an organism, an animal, or a plant, or archaea, or bacteria, or whatever it is, by its genus and species names. So the giant squid is Architeuthis kirkii. Okay, the great white shark, Carcharodon carcharias, and the bottlenose dolphin, Tursiops truncatus, Arctocephalus fosteri, Arctocephalus pusilius, for the two seals. Okay, so there you go. So it's basically you're following these things back, and you can when they had a common ancestor. And you could see that these two seals are much more closely related than say, a seal and a great white shark. And you could see that if you go back, a great white shark is more closely related to a dolphin or either of these seals than it is to a giant squid, because the common ancestor for the giant squid and the great white shark is back up here in the Animalia. All right. So, what about human beings? Okay, we're always interested in ourselves. The kingdom, Animalia, phylum, Chordata. Okay, so it's the same as all of those species, right up until here. The Chordata. Okay, we've lost the squid, but we're still in the same grouping as the seals and the shark and the dolphin. And Mammalia, okay, so we're still in the same grouping as the seals and the dolphin. Okay, here are the ones that we had before, Cetacea and Pinnipedia, and I'm probably mispronouncing Cetacea. And then primates. So we're primates, or primates for our order. Our family, Hominidae, Hominidae, that's right, Hominidae. We're often referred to as hominids, things that are like great apes. Saboons are not hominids, but they are primates. Yeah. Okay, so there we go. And then our genus is Homo and Sapiens. And in fact, there are actually three what we call subspecies of sapiens. Okay, so they may have been different species, or there may have been different subspecies. We don't really know. Subspecies are things, further groupings that would have different characteristics, but can still interbreed and produce a viable offspring. Okay, so Neanderthals, nobody's really sure whether they were a different species, and that when Homo sapiens came in and started competing with them, they quickly were just exterminated, or whether we might have even interbred with Neanderthals. So it could have been Homo neanderthalis, or it could have been Homo sapiens neanderthalis. So we don't really know whether these, and this adultu, this is another very smallish hominid, Homo, it was a very smallish sort of person, okay? But did we exterminate these in competition, or did we interbreed with these and only Homo sapiens what we are now remain? The question is still being argued. Okay, and of course it's interesting because if you order these things based on what you can see, maybe different scientists, as we saw before with those different classifications that we started with, might have different ways of, or they might have different features that they order things on and give different weight to those different features, and so you might come up with different systems of classification. And this is certainly not set in stone, all of these classifications, because we're constantly sort of debating about what order these things and what groupings they should be in. But DNA evidence has given us a very good clue about, you can look back at how many changes there have been from one grouping to another, and you can actually sort of see how similar the DNA is. And that's because DNA, over the long term, tends to accumulate mutations at a rate that stays fairly constant. So over time, the rate of mutations in DNA is very constant, and so if you look back, you can see how many mutations difference there are, how much difference there is in the DNA between one grouping and another, and try to extrapolate how far back it was since they had a common ancestor. Okay. So remember, with binomial nomenclature, which is what we call genus and species name, remember the way that it was written before would be Homo sapiens. So there you go. You got your capital on your genus and your lowercase on your sapiens. And here's a little practice for you. And you've got some practice in your theory book. And so you can see that these ones are all written incorrectly. Okay? And so you can try to rewrite these in correct binomial nomenclature. Okay, so if we're going to say this SP, should have put this in there. Okay, SP stands for species. So Haliotis species, Haliotis would be our Pawa. Okay, so we've got two different species, the Haliotis australis and Haliotis iris. So if you've only got one species and you're just going to refer to it by Haliotis species, you not maybe know that it's a type of Pawa, but you don't know which type. So you might have identified it down to the genus, but not the species. So you'll say Haliotis spa. which means SP, which is short for the species, but we don't know what the genus or what that species is. We do know it's a Haliotis genus, so we can identify it as Haliotis. But if you have more than one species, maybe you've got some Haliotis iris and some Haliotis australis, and you're grouping them for a paper. You just want to put the PAWA together in a paper, and you're talking about different, like let's say it's the effects of the renal oil on different organisms. So you're going to have a generally refer to what happened to PAWA from the effects of the oil. And so you would say Haliotis SPP period. So SPP would mean multiple species of the same genus. Okay, we'll leave it from there. Go try the examples in your theory book, and there's a whole section on your theory book on taxonomy.